Question 21. Simplify 8a squared minus 12ab over 2ab. When you're having subtraction or minus like in this case, you don't just cancel with the denominator. You have to first factorize the numerator. Also, if it were to be addition, you do the same. But if it were to be division or multiplication, you can actually say 2 in 2, 1, 2 in 8, 4. You can say a in this a or in this a 1, you get the a out and you get the b out. Then you can multiply what is left. But in this case, since it's subtraction, and also if it were to be addition, you don't do such. That's the technicality of this question. You have to first factorize the numerator, find what is common. Let's go on to solve the question. By factorizing the numerator, we have this equals, in this 8 you can find 4, in this 12 you can also find 4. So as regards the numerical value of what is common in both 8a squared and minus 12ab, you have 4. Also in both 8a squared and 12ab, we also have a in common. There are two a's here, there's a single a here. So you pick one of the a's, you have 4a common in both 8a squared and minus 12ab. There's no b in this 8a squared, so what is common is just 4a. You open your bracket, you divide 8a squared by what is common in both of them. In other words, you can just say the HCF. So you have 8a squared over 4a. This 8a squared is 8 times a over 4 times a. The a cancels one of the a. 4 here 1, 4 in 8 2. You'll be left with 2a. So you have 2a in the bracket. To be sure of what you've done, if you multiply 4a times 2a, you get 8a squared. You have to also take the 4a out of this minus 12ab. Since this 4a is positive, you don't have a problem. So it's just minus. You just focus on the 12ab. If it were to be minus 4a that was common, this negative 12ab will change to positive. But since this 4a is positive, it's like saying positive divided by negative will give you negative. So the negative still stands. So you have 12ab divided by 4a. Let's just do it a rough one. 4 here 1, 4 in 12, that's 3. A cancels a. What you're left with is 3b. So 4a in 12ab will give you 3b. Now you factorized the numerator. So you have 4a into open bracket, 2a minus 3b close bracket. If you multiply this 4a times this 3b, you get 12ab. Then you still have this over 2ab. Now since you have this 4a linked to this open bracket 2a minus 3b close bracket by multiplication, you can then cancel out. That is, you're having a multiplication sign here. You can't work with the bracket, you can only work on the 4. 2 here 1, 2 in 4 2. A cancels a, you'll be having 2 into open bracket 2a minus 3b close bracket left at the numerator over b at the denominator. You can't just say this b cancels this b. This is not acceptable in math, or it doesn't work like that in math. And since the b cannot go in any other thing, you can then ignore the denominator at this point, then multiply this 2 by this 2a and minus 3b to get your full mark. This 2 affects both the 2a and the minus 3b. So 2 times 2a will give you 4a minus 2 times 3b. 2 times 3 is 6 with the b, 6b over b. This is actually your final answer. 4a minus 6b over b. This is the final answer. You can't do any other thing to it. There's another method of doing this, although it's not standard in math. Say we have 8a squared minus 12ab over 2ab. If you want to divide these two by the numerator, noting that they are linked by subtraction in this case, and also if these two terms were linked by addition, this same step will apply. The 2 will not just go in the 8, but it will also go in the 12. So you can say 2 here 1, 2 in 8 is 4, and 2 in 12 is 6. So you have 4a squared minus 6ab at the numerator. Then you have ab at the denominator. The reason why we divided both terms at the numerator level by 2 is because 2 can go in both of them. A can also go in both of them, but B can only go in one. And if B can only go in one, we don't use it. A can go in both 4a squared and also 6ab. Let's rewrite so we can get it clearly. So you are left with 4a squared minus 6ab over ab. Since you have a in 4a squared and also a in 6ab, you can then use your a. A in a1, a in 4a squared, we take one of the two a's, you left with 1a. Because 4a squared is the same thing as 4 times a times a. And if divided by a, the a will take one of the a's, then you'll be left with 4a. Then you also take the a in the 6ab. In the 6ab, a will take the a, you'll be left with 6b. So your answer, same as using the first method, will be 4a minus 6b over b. You can see you arrived at the same result. If there were to be 3 terms at the numerator, whatever value in the denominator you are dividing them by must go in all 3 terms. That's the principle guiding this method. But note, if at the denominator you have a negative 2, it doesn't work that way. Meaning you have to just use this method where you have to factorize both the numerator and the denominator before you start dividing to bring down to the lowest term.